right, so I'm going to be talking about services and Rails, not necessarily services in Rails. That's also awesome, but this is going to be on services and Rails and focusing on some of the things that we don't talk about often. Maybe not the technology side of things, maybe more of the organizational side of things and some of the other things that go into it. So this is me. My name is Brian. I work on the Rails team at Yammer. And one of the things that Rails team does is figure out these chunks of functionality, how we can extract these into services, work with other teams in the organization to do that, and then integrate those things back into the Rails app. I also love Zelda and Ruby and music, and yeah. But first, so this is my first conference talk, which I'm really excited about. But it's been a while. Thank you. It's been a while since I've given a presentation, so when I sat down to figure out, like, what template do I use, what do I make this thing look like, I looked through some Yammer templates we had and some Microsoft templates that we had, and, well, I'll preface it with this, too. I kind of have a pet peeve about, like, talks that have a title, and then they don't ever talk about, like, what the title was about, so I wanted to make sure I didn't do that. And so I found this in one of our templates, and I thought it was cool. It says, use full bleed photos, because pictures can set a mood or evoke emotion, making for a more memorable presentation. So I thought, what better way to do it than with this exact slide? Like, I copied this over. And so this guy is going to help tell us when there's some shit they don't tell you. You'll see this guy, and he'll be helping us convey that message. So we're going to start with the first one here. Transition into him. So what I'm going to talk about might not apply to you yet. If you're building a startup to determine viability, a lot of this you can probably ignore and just get it done. You're going to add a lot of complexity with services, and you might not have enough information to do this yet. But once you know you need to scale, you're going to have to do some things that aren't comfortable. I'm expecting this audience, maybe some of this will apply more, so that's awesome. All right, let's continue. So we have a huge fucking Rails app. It is massive. Oh God, what did I do? Everything is gone. Okay, here we go. Huge fucking, I just wanted to say fucking again. So we have 300 plus models. We have 200 controllers. This thing is backed by 20 plus JVM services. Some of these services do over 1 billion requests a day. But at the end of the day, we still have a huge Rails app. And this gets harder as we go, but largely we've been okay with this. We've been able to address it through kind of chipping it away, building services. But things are still painful when we get into things like sharding or upgrading Rails. Those become like these all or nothing projects at that point. And that's still hard. We don't have a solution for that, but this makes it better. So why build services? What does that get us? I'm going to talk pretty briefly about service-oriented architectures. I'm sure a lot of this will be familiar to you guys. But one of the goals is that we want these components that scale individually. When you have these small focused services, they're much more versatile. They allow for easier reusability. So here's our Rails app. When we started to build like our search stack of things, we were able, because of some prior search stack experiences that people brought, we were able to separate these things out into different pieces. We have this denormalized store of data, which is Flattery in the middle here. It stores representations of data in Rails, denormalized. And then these other two services work with it. We have an indexing service and then our search interface. So when we wanted to add on another piece of this, it was pretty easy. We could use the same structure. We got a lot of reusability out of it. This is our autocomplete service, building off the same indexes, off the same denormalized store that we already were moving outside of Rails. And again, when we wanted to export data, we have this service called Slurpee that would slurp data out of Flattery, and we would also get that reusability win. And this is also great because now we have these pieces that can scale individually. So when we talk about scalability, it's much easier to scale out a service. We have these pieces that are broken up. We have a much better idea of each service's specific needs and its performance patterns, and we can measure this. If you have a monolithic architecture, it means that you are allocating resources to everything. So we don't have to throw resources at the whole stack, which may or may not be needed. And this is kind of all enabled through this next benefit, which is loose coupling, like I said, smaller and more focused pieces. We have these encapsulated concerns. We can push out updates independently to each of these pieces. And we can change out entire libraries or platforms or entire technologies without telling anyone. We're working on changing our entire file storage backend right now. And largely, it's gone pretty smoothly. We've been able to take out the service and put a new one in place. It hasn't been completely clean, and that's probably places that we've screwed up. But we can fix those now as we go back through. So kind of a second goal of services and service-oriented architecture is maintaining code bases that scale across our organization. We have an engineering team of about, I think, 150 engineers. And if you've worked on a monolithic app in that environment, you've probably stepped on people, and you have to maintain a lot of this application knowledge. Like, we have 300 models, 200 controllers. You have to keep all that in your head to know how these things work. And services enables us to kind of decouple that. And then we also get this benefit, which is not in the computing sense of distributed execution, but in the development sense. This is enabled by loose coupling again. And because we have loose coupling, we can assign a team to the service, and it's a team to the client, and they can coordinate and agree how these things are going to talk to each other. And a lot of times what we'll do is we'll build dummy pieces along the way so that this team's not waiting on this team to finish their component. This team can implement this interface that does nothing yet, and this team can send it data that's not right yet, and both teams will become unblocked. They can move forward, and then as these things start to get implemented, we can have this end-to-end test of what this is going to look like. So here's the dude again. This obviously doesn't happen overnight, like I alluded to a little while ago. When you're starting out building your application or your startup, all of this is a lot of additional complexity, and it prevents you from shipping product quickly, which is kind of your main goal. With a single, undivided code base, you can kind of change things really quickly. You can access data layers directly. You can share a lot of code easily. You can avoid overhead that managing services entails. Then when you start to build services, you realize all of that was making your life harder now. And things, you're going to learn things iteratively along the way. So as you learn about building this application, you learn about its usage patterns and how you can split this thing up better. So you're not going to wake up one morning with services. And we found that sometimes this even requires organizational change. And we talk about this a lot, Conway's Law. We like to think about it that organizations that are optimized to avoid bottlenecks will also create code that is meant to avoid bottlenecks. And this is how what Conway's Law says. Organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. So it's hard to think about services if we don't think about our development teams in the same way. A lot of organizations divide their departments vertically or horizontally, which can lead to silos within the organization, or people are just working on the same thing day to day, and that can get tiresome. So this barrier forces people to get attached to their turf, inhibits communication and decision making. I have an example here. So this is something we had early on at Yammer. This is the messaging team. And their domain kind of looked like this. They implemented this service, and they also had responsibility in the Rails side of things. We have a service that handles our message feeds, and the team that supported that also worked on the Rails side of things. They took both sides of this implementation. And so the messaging team decided on the interface and implements both sides. They have really siloed knowledge of the system. It isn't always the most important thing that they can be working on. And then how do we keep creating feature teams going forward? This doesn't scale well. They have a lot of responsibility. It's really tightly coupled. So we took a step back and we looked at this. And we came up with something that that scaled a little better and worked more like Conway's Law. We divided it up like this. And so we have a team, the Rails team, that would take care of the implementations of services onto the Rails stack and coordinate with the core services team on how these things would work. The Rails team would have to know a lot about the monolithic app and how it works, and that's still a problem. It's still a bottleneck for us. But the idea being that we could iteratively move things into services and reduce the amount of knowledge on the Rails side is a big win. And we had to take this a step further too. And this is one of the things we talk about a lot, and it's cross-functional teams. And so instead of having like the messaging team when we work on things, we create these cross-functional teams. When we're creating a new service or a feature, we put together one of these teams, and we take representatives from each of our functional teams for whatever aspect of the project we need. We bring in 2 to 10 people for a project from whatever functional teams are necessary, and they work on a project for anywhere from 2 to 10 weeks. And people are constantly working on new and different things that way with new people. So this is kind of what a team would look like. We would have maybe 2 Rails engineers, a core services engineer, maybe a mobile client engineer, there's some roles outside of engineering and product as well, but largely what we're concerned about for this talk is this. And so it creates this autonomous, well-informed, decentralized design process. And these teams have great discretion, but it produces well-designed, isolated, reusable systems. And the key here is that these teams are ephemeral. They come together, they solve the problem, and then each team member moves on to something else. So they'll spin up, they'll learn the domain, they'll take advantage of the distributed execution so we can work on things in parallel, and they'll coordinate on the API between the services and the client. And so like everything, this has trade-offs as well. We have some costs with not having siloed experts. Some would argue that this is a benefit, but there is a cost involved with teams constantly having to learn a new domain. We're okay with that. It's a small cost to pay for what we get out of it. And we have to be careful not to couple the API implementation to the client. If we're working with mobile clients and as mobile clients become smarter and need customized data, we have to make sure that we're keeping this in mind. And then after a project is completed and the team's disbanded, we have to figure out a way to support this thing still. So this is still something we have a support team internally that's also a cross-functional team, so that helps us address this. But it's still a point of concern. And so obviously there's more than one way to do this. Services can live in many different ways. One of the easiest ways is if you just put them all behind Rails. They don't have to talk to the outside world. It's probably going to look like this for a while as you figure out these other problems. This gets us some partial win, but we still have to use Rails resources to get to these services, which is still annoying, but we're okay with it. We're pulling things out. We're working on this problem. But eventually the time comes where you want to talk directly to a service. And so sometimes this is easy. We have a service that we call Mugshot that handles dynamically resizing avatars and other images for us. And that's something that Rails doesn't need to do. The browser can talk directly to the service, and it works pretty well. But most of the time, you'll have to figure out authentication if you want to talk directly to services too. It starts to get harder. And then eventually, you're going to want to talk to the data that's in Postgres maybe directly. There's going to come a point where you need to work around Rails to get to your data. And reading from the database isn't the worst thing. It's not great. But writing that database becomes a nightmare. The problem with reading is that in this diagram, Postgres isn't really our database. Memcache is our database. And Rails knows about this caching layer, but our services don't. So talking to the database directly generates a lot of load that we don't normally get when we use our Rails app. We have like a 98% cache hit rate. It goes directly to Memcache instead of ever hitting Postgres. And so this is part of the problem that we have. Active Record holds our data hostage. And it's fine for the most part. It made things easy in the beginning as we built our app. But now we have to tear down some of the code that worked well and figure out how to make it work in this new world. And so don't get me wrong, Active Record is awesome. We have these callbacks and hooks. We have validations. We can have state machines in it. We can do cache invalidation relatively easily. We use a gem called record cache that handles storing everything in memcache. And we rely pretty heavily on that. So this stuff is awesome until you start to detangle the data and access it from a service or try and move it outside of a service. And it quickly turns into this. Active Record, I have all these hooks and callbacks everywhere. I have validations that I need to worry about, state machines, cache invalidation. It starts to get complex quickly. And so we do have some options. We do this in a number of different ways. Some people might prefer not to use Active Record. We still use it pretty heavily. One of the ways we address this a lot of times is we use our services kind of as indexes and just store IDs and pull things back through Rails, hydrate those things, and then serve it out through Rails. We're toying around with an idea now, and we're calling them like bodega services, where we move this data completely to a service, and we hit that service instead of the database. We can hide a lot of our like sharding and caching concerns behind that service at that point. And the goal is obviously, right now we're hitting memcache for these things. The service needs to be just as quick to do that. So once we've decided we want to move data out of our Rails app, moving data means we're going to ultimately duplicate this stuff. This is pretty much our option. The chances are if you're like us, you can't have downtime, and you can't just move data across. And what if the service doesn't work like you thought it was going to? Rolling back is really hard. You need a backup plan. So largely, we do something with double dispatching, where we will start to backfill data to a service. We'll write data to the database and post to the service at the same time. While we're doing this, the service can be monitored and profiled, and we can make incremental steps to move over to our services. And the backfill is pretty nice because we get a peek into the scalability of this service. We're going to be putting a lot of data into it much faster than we would if traffic was coming into it. And so we can typically gauge what this thing's going to handle, and we can use that to plan our capacity and just know how we expect this thing to perform. So once we've done this, the problem is we now have duplicate data. We have data in these two different places. Who cleans this up? We need to do it quickly because this is confusing to developers. They see data in both places. They don't know which is the right source of this. And we do fuck this up from time to time, and data sticks around. It's confusing. I know personally I've fucked this up. With the mugshot services, we had to move mugshots outside of Rails over to the service, and we still do have some avatars in the Rails app. It's mostly disconnected from anything, but they still exist there. And it's really confusing. This is part of our trade-off in cross-functional teams. So our team disbands. We need a way to make sure this still gets wrapped up. We need to know when we're okay with going all in. And this is largely one of the concerns, is the old way is really comfortable. We have this escape route if this thing's not working. We can quickly just kind of go back to the way things were comfortable. So we have to be okay with breaking out of our comfort zone and dealing with these new issues that come up when we go completely to the service, and we won't be able to jump back to safety anymore. But don't get me wrong, you don't want to strand yourself. There should be an incremental period, but eventually you have to make that call to completely switch. There's costs with maintaining this backup plan, and it largely isn't worth it. On that note, we also want to make shit really easy for developers. If you don't have a good story with your development environment, you're not going to be able to keep moving quickly as if you're on just a single Rails app. Part of the big win with services is not having to worry about configuring them or how they work, or you don't have to dig into them until you need to like learn what this thing does. And if it isn't easy, developers might just wander back into their comfort zone, add to your monolith, instead of going the route with services. Basically what I'm saying is use Vagrant. We use this really heavily. It allows our development environment to closely reflect production. We get to run all these services locally in a similar environment, and we can keep up with services that are rapidly changing. But your developers need tools probably to manage all this complexity. We've built this thing in-house. We call up Soup Kitchen, which manages Vagrant. And it's part of the win of services that I don't have to worry about any of these services until I need to. Just let me update them. When these red things come up, I click update. But aside from that, I largely don't care. Just let me work, get my shit done, and then when I need to worry about these things, I can dig into the services individually. And so another part of making this easy is deployment. You need a system that's going to allow you to add new services quickly. You're going to still have to move those services out to production. We have quite a few apps and services, and we need any engineer to be able to roll these things out. Easy to deploy these services, and we also need to maintain things like stable for production, pre-release packages for our development environments. And we do it with a tool that we built, another tool that we built in-house called Deploymacy. It's our one-click deploy system. Unfortunately, we haven't open sourced it yet, but we talk about it from time to time. It's pretty coupled to some of our conventions, but it allows any engineer to effortlessly add new services for deployment. They can come here, and we can push it out to different environments. And then our developer environments kind of couple onto this as well. Another thing that's going to be important is monitoring and alerting. You're going to want to monitor performance, not just on one app now, on these 20 different services. Capacity planning, QDEPs, you're going to have to look at these things. Reachability from dependent clients. There are lots of different tools that we use for this. Monitoring, I think we use Ganglia, and for alerting, some other tools. I think we used to use Zabbix. We're kind of transitioning away from that. And then for reachability from dependent clients, we have some tools we've built in-house that check different endpoints, make sure they're returning the right things. And so mostly this comes down to having standardized tools, your deployment systems, how you're setting these things up, and then all the way down to like having similar response formats and data protocols and monitoring interfaces, deployment stories, dependency management across these. It makes your world infinitely easier than trying to manage tons of unique little special snowflakes that all speak different languages. This is what we use for a lot of our services. This is a Java library called DropWizard that kind of came out as an abstraction from services that we built early on. And it's basically packaged together all the libraries that we use when we build a Java service. We get a really simple production-ready service, monitored, alerting, reporting metrics. But this isn't the only way to do it. This is how we do it. It may or may not work for you guys. I know I prefer writing Ruby. I don't like writing Java, and I try and stay away from it. But this is a tool that we use. And so service-oriented architectures have trade-offs as well. One of the largest ones being that complex systems fail. You now have to think about a lot more. You have to think about degrading for unavailable services, chasing issues through multiple levels of indirection. People don't know where this problem's happening. The place that's throwing the alert might not be the place that's causing the issue. You could have queues backing up because the service is becoming slow. You have to worry about all this stuff now. So one of the trade-offs is handling this unavailability. These transactions aren't free. We do have to worry about talking to these different services now where we could just go to one single place in our database before we get these things. And so we have to worry about that. Maybe we have to parallelize some calls. We also have APIs that are much harder to change. And there's no sense of like this atomic deploy anymore. We can't just deploy our app and it works. We have to worry about clients that are on both sides of the deploy. Coordinated deploys rarely work well. You really have to consider both sides of your deploy. This went a lot faster than I thought it was going to. So to recap, you should always be reevaluating your costs and their viability. And by this, I don't mean the financials. I'm talking about decisions you've made, and if they're still the right decisions, are you still okay with the trade-offs you've made? Is something slowing you down? Know what an inflection point looks like in your app and what that means to your software. Is it time to start breaking things down to services? But don't scale before you need to. but be ready for it. Once you've determined that you need to scale with services and you can take on the additional complexity, you'll need an organization that supports building services. And this could be much more than just changing your development structure or how you organize as a team, but it means giving priority to building the kinds of tools you need and creating a culture around services. Some things are going to get a lot harder. Development's going to be more complicated, but that's okay. We reduce the amount of required effort in some places, and as the system gets larger, it's much more manageable. There's a graph that I've seen that shows like this monolith, and the trend is much different than like services. I should have had the graph in here. And so you also need tools that allow you to keep moving fast. You can't building services can't slow you down. You still have customers. You still need to deliver value to them constantly. And they don't and shouldn't care about any of this. But they're going to care if things start going wrong, if they can't get to what they want to do. And additionally, if developers can't build services easy and they're up against a deadline, they might just start adding to the monolith again, and that doesn't help solve our problem. It's easier for them, and they can worry about that later. And then finally, one of the things we talk about a lot at Yammer is you're going to make mistakes, but be ready to acknowledge and recover from it. Be ready to be wrong. We've rewritten our search stack probably 3 different times, but we learned a lot about building services and what we needed as we went along. This is the same in code, too. We look back at what we wrote, and we want to go back and punch ourselves in the face a lot of times. Decisions about building services and how you organize can be the same way. Don't assume that the decisions you made yesterday are still going to be the same decisions, correct decisions today. It could have very well been the best decision at the time, but today that could be much different. And this is really hard to do, like I said. We still have a huge Rails app. We haven't solved that problem yet. But we've made a lot of incremental progress towards getting this right. We've misstepped and gotten some of this wrong, but we're okay with admitting that some of the things we've done are wrong, correcting those mistakes, and moving forward again. And that's all I have for you guys. You can